Hello everyone. Today we'll go over chapter 3.3, Solving Right Triangles, part 3. Example 1. Solve the unknown length. We're looking for length x, and you see two triangles for one here, the first triangle, and a second triangle here. It's important to recognize two triangles in this case because we're going to have to find this length. I'll denote it as x1. And we need to find this length called x2, and we'll state that x is a sum of x1 and x2. All right, so we have an idea how to find this length now. Let's start with the right-hand triangle here. And you don't have to draw a separate triangle for this. I'm just doing it so I could write on it instead of making a big mess here. So 4.3 is a right angle here and 15 degrees here. And we're looking for x2. All right, so we have, let's first label the sides. We have an angle here, and the side that's across from that angle is called the opposite side. And this is called adjacent side. And recall back to SOHCAHTOA, which ratio has opposite and adjacent? It turns out tangent has it. So tan theta equals opposite over adjacent. Let's sub in the values we know. Tan of 15 degrees equals opposite side is 4.3, adjacent is x, subscription of 2. We'll multiply both sides by x2. We have x2 times tan of 15 equals 4.3. And then we're going to divide both sides by tan 15. And again, it is tan function is a package, so you cannot divide 10 or 15 separately. It has to be together. So we have x2 equals 4.3 divided by tan of 15. 4.3 divided by tan of 15. We have 16.05. 16.05 centimeter. I like to keep 2 decimal places just in case, but understand that there's only 1 decimal place that's listed in the diagram, so at the end I'm going to round it up to 1 decimal place. For now, let's keep it 2 in case there's any issues at the end. You always round up at the end. All right, so we have x2, so let's replace this. x2 equals 16.05 centimeter. We are now going to look for x1, and let's set up the triangle. So we have this one, 24 degrees, 4.3 here, and the right angle here. We're looking for x1. Angles given here. The side that's across from the angle is the opposite side, and adjacent is 4.3. And again, which trig ratio uses opposite and adjacent? This time again, it's tangent. So we'll stick to tangent again. Tan theta equals opposite over adjacent. Sub in all the values. Opposite is x1 over adjacent 4.3. We'll multiply both sides by 4.3. So we have 4.3 times tan of 24 equals x1. 4.3 times 10 of 24 equals 1.91. X1 equals 1.91 centimeter. And then finally we can solve for x now. So this one here is 1.91 centimeter. So x equals x1 plus x2. Therefore, x1 is 1.91 and x2 is 16.05. And this turns out to be 17.96 centimeter. And then I'll round this up to 1 decimal place, but then it turns out to be 18.0 centimeter. So whenever the diagram shows you 1 decimal place, it's okay to stick to 1 decimal place, but this rounding has to happen at the end, or else you're just gonna get a higher value. Alright, so that's it for example 1, part A. Let's take a look at part B. So similar triangle, let's take a look. Similar triangle, but this time a triangle is embedded in another triangle. So there's this one, triangle number 1, and then triangle number 2. Okay? Alright, so let's take a look at what we can do to solve for this value x. In order for us to know x, we do need to know the entire length of the adjacent side of the triangle. Let's denote it as a capital D for having, and this one for little d. Okay, so it's okay to use capital letter if you want to make sure that something's bigger. So I would definitely go for the larger value to be a capital letter. Okay, so I'm going to say that x equals capital D minus little d. Okay, so we're going to leave it here. Let's solve for the missing values. We'll start with the smaller triangle first. So let's see, 40 degrees here. This is D, 7.7, right angle here. All right, so when we're labeling the sides, the opposite sides here, adjacent side here. So katoa, and the ratio we need to use is opposite and adjacent, so tangent. Tan theta equals opposite of adjacent. Tan of 40 equals opposite is 7.7. Adjacent is D. You multiply both sides by D, and you should get D times tan of 40 equals 7.7. Divide both sides by tan of 40. So you get D equals 7.7 over tan of 40. 7.7 over tan of 40. So 9.18. 9.18 centimeter for now. Okay, so we have found the little d, so we just need to find the capital D now. Alright, so let's take a look at the bigger triangle, the blue triangle here. We're going to set it up. Now we need to find the capital D, so we need to use a bigger triangle. This is 18 degrees, right angle here, and 7.7 here. All right, so the angle's given here. The side that's across from that angle is called the opposite. This is adjacent. And again, we have to use tangent ratio. It seems like tangent ratio is a very common one, but it really depends. It doesn't happen all the time, so make sure to double check. Opposite over adjacent, so we have 10 of 18 equals 7.7 over capital D. You multiply both sides by D. So you have D times 10 of 18 equals 7.7. Divide both sides by 10 of 18. You get capital D equal to 7.7 over 10 of 18. Okay, so let's take a look. 7.7 over 10 of 18 equals 23.70. 23.70 centimeter. All right, so we have found another value here. So now we can go back to our starred, right here, starred statement. We can say since x equals d minus the capital D minus little 1, we can do 23.70 minus 9.18, and this one turns out to be 14.52 centimeter. So we have found x. That's it for example 1. Moving on to example 2, part A. Solve for the unknown angle. The angle we're looking for is theta, which is this angle. We are only given the opposite side of the angle theta and a different triangle. So we have two triangles, one here and one here. Okay, so let's kind of think about what we need minimum to find the angle theta. We do need at least two sides to figure out the angle in a right triangle. Either we need to know this side over here, or we need to know this side over here. How do you decide what we really need to figure out? So basically, in order for us to solve for theta, we do need to find the shared side. The shared side of two triangles, pretty much this. This is a hypotenuse of that first triangle, and also a hypotenuse of a second triangle. So I'm just going to label it as H. H here. So once we find that, we can actually solve for theta. And we could look for the H using Pythagorean theorem, because now we have two sides with the values given to us. So we can actually just punch into a formula and figure it out. All right, so let's take a look at Pythagorean theorem. So the rule is the formula is 9.4 all squared plus 6.1 all squared equals h squared. So 9.4 is 9.4 squared is 88.36, and 6.1 squared is 37.21, and this equals to h squared. And when you add those two together, you get 125.57. And then in order for us to get rid of that square, we need to square root both sides. So we get 11.21 equals h. So we have found the value of h. We're going to use h in order for us to solve for theta. So let's draw the triangle here. This is theta. H is 11.21 right here. So this is our triangle. We're looking for theta. And the side that's across from theta is called the opposite side, and hypotenuse for the longest side of a triangle. All right, so using SOHCAHTOA, we double check which ratio we need to use. We need to use O and H. So therefore we have O and H, sine. So sine theta equals opposite over hypotenuse. Sine theta equals opposite is 8, hypotenuse 11.21. And like before, when you're looking for the angle theta, you do need to use an inverse trig function. In order to revert back that trig function, we need inverse sine function here. And whatever that's on the right-hand side goes straight into the bracket. All right, so let's punch into our calculator. Arc sine of 8 over 11.21 equals 45.53. Equals 45.53 degrees. All right, so either you can leave it in two decimal places or you can round down to 45 degrees, 0.5 degrees. I'll take either or. So we have found the missing angle. For part B, we do have a really weird shape, but let's take a look at the angle we're looking for. We're looking for this angle, the tiny angle. Okay, so this angle is a combination of this angle, or like this angle, let's say that's beta, and little angles alpha. Then our theta, angle theta, is the bigger angle minus the little angle alpha. Okay, so make sure to double check what is the angle it's referring to. We're looking at that tiny angle there. It should be pretty small. All right, so same step as example 2 part A. We're going to first find the value for the shared side. And it looks like these two triangles, so first triangle's here, and the second triangle's right here, they both share this one particular side. This one right here. So I'm gonna denote that as H. Okay, so we will need to find that H in order to solve for thetas, or the angles. Right, so let me just form, let's start with this triangle, where the right triangle's here, and this is angle beta, and this is H, and we know this is 6. All right, so can we actually do, oh yeah, and this is 48. Okay, so we don't know what b is, but you can actually quickly solve that first using the sum of interior angle inside a triangle. We know that angle inside a triangle must add up to 180 degrees. So we're just going to take 180 minus 90, which is the right angle there, minus 48. This should equal to angle beta. And so 90 minus 48, you get beta equals 42 degrees. So we already found out what beta is. All right. And I guess it really doesn't matter, but you don't want to use beta to solve h, just in case this value is decimal and it doesn't end nicely, then you might have to just stick to the given number, which is 48 degrees. So using this angle, let's label the sides. The side that's across from that angle is called the opposite side. And h is the hypotenuse, so the longest side of a triangle, of a right triangle. So we have opposite and hypotenuse, and we have an angle. So SOHCAHTOA, which ratio has opposite and hypotenuse? Looks like sine would be the correct one. So sine of beta equals opposite over hypotenuse. Sine of 48 degrees equals opposite 6, and hypotenuse is h. Let's solve for h. And by multiplying h to both sides, then you divide both sides by sine of 48. You get h equals 6 divided by sine of 48. 6 divided by sine of 48. Alright, so we get 8.07. 8.07. And I'll just hold on to it. So we have found this one, this value here, equals 8.07. Okay, so now we could solve for alpha and theta now. Let's set up the second triangle here. We have, this is alpha, this is 8.07, right angle here, and this is 7 here. Okay, so this time we are looking for angle alpha, so make sure to recall back to inverse trig. So angle is here, the side that's across from it is the opposite side, and then adjacent on the bottom here. So tangent would be the correct ratio. Alpha equals, no, theta equals that. So tan of alpha equals 7 over 8.07. So when we're looking for alpha, we need to inverse tan. Either arctan or inverse tan, however you like to read it. Sometimes your calculator has arctan on it, so same thing. Alright, so inverse tan of 7 over 8.07. Inverse tan of 7 divided by 8.07. You get 40.94 degrees. 40.94 degrees for alpha. Alright, we're not done yet. One more step. We stated that theta equals beta minus alpha. So the bigger angle is beta. So beta, theta equals beta minus alpha. So beta is 42 degrees and alpha is 40.94 degrees. And this turns out to be 1.06. If you want to round up to one decimal place, it's 1.1 degrees. So that's it for this section.